When did you realize your research topics would be climate change?
As an undergraduate in college, I studied applied math and physics, and then I went off to graduate school to do a PhD in theoretical physics. And I passed all of my exams, but I realized that I wasn't that passionate about what I was working on, and so I decided to open up the catalog at the university that I was studying at, Yale University, and I just started leafing through the catalog, seeing what other research was being done at the university, and I saw that there was a professor in the Department of Geology and Geophysics who was using math and physics to model Earth's climate system, and that sounded like a fascinating problem to me, so I went and talked with him, and pretty soon I was doing my PhD thesis on climate modeling with this professor.
This is a kind of personal question. And what is your daily routine?
Oh, my daily routine. I get up in the morning and I make coffee, and I spend about an hour going through accumulated emails and looking at my Twitter feed and reading any news articles that morning that have appeared about climate change. And then depending on the day, I may go off and teach. I teach several courses at Penn State University, or I may start working on some of the scientific research problems that I work on. And a lot of the time I spend interacting with other scientists, my collaborators, and journalists, talking with journalists. And some days I give public lectures, and so it sort of depends on the day. I wear several hats, as we say in English, because I teach and I advise students, but I also do scientific research, and I'm also very committed to public education and outreach. And so it's really a mix of activities, but the one thing that's true is every day starts out with me making some coffee and going through my emails.
Could you describe us the theory of the hockey stick?
So this is a graph that my co-authors and I constructed and published 20 years ago now. It's 2 decades old. And what we did was to use what are known as proxy data. These are things like tree rings and corals and ice cores that tell us something about how climate changed in the distant past. Because we only have about a century of widespread thermometer measurements around the world. So we know how the Earth's temperature has changed over the past century or so, but to gain a longer-term picture of how the climate has changed, we need to turn to these other sorts of data, these tree rings, these corals, these ice cores. And so what we did 20 years ago was to take all of the information that was available in a global data set of these so-called proxy data to reconstruct how Earth's temperature had changed in the distant past. And when we did that, and when we averaged our results over the entire northern hemisphere, we got a graph that showed that temperatures were relatively mild about 1,000 years ago, and then they cooled as we got into the period we know as the Little Ice Age, when many of the glaciers in the Alps here expanded to their maximum extent, and then temperatures shoot up. And so the curve looks like what we in the United States call a hockey stick. It's used in the game of hockey. And the blade of the hockey stick is the modern warming. And what it tells us is that the recent warming that we have seen is unprecedented as far back as we can go. And that implies that there's something unusual taking place. We now understand what that is. It's the human impact on our climate. It's the warming of the planet due to the burning of fossil fuels and the buildup of so-called greenhouse gases like carbon dioxide in the atmosphere that are warming the planet.
We saw the glaciers upstairs, so how would it be alive without glaciers?
Well, I think that the melt, the water, the fresh water that runs off from the glaciers around the world provides fresh water to about 25% of the world's population. So it's a very critical source of fresh water. And with climate change, we're actually seeing many regions, including the Alps, are drying out. There's less water The ice is melting, so that's what we call it's a double whammy. It's two effects at the same time that really challenge our water resource needs. So this is part of a larger problem, which is that climate change is in fact leading to a decrease in available fresh water around the world, fresh water that is needed by a growing global population of 7.5 billion people and growing. So this is an important part of it. The loss of these glaciers is a problem for people who need the fresh water that comes from these glaciers, but also it's a problem for the ecosystems, for the animals that live in that environment. These are unique environments. The glaciers, the mountain glaciers around the world are a unique environment that provides a home to many unique species, and we are losing that home because of the warming of the planet.
What is the most virtuous country in the world?
Well, you know, there's a certain level of irony when you look at the problem of fossil fuel burning and climate change, which is that much of the developing world, in the tropical regions of the world in particular, have had very little role in creating this problem. They use very little energy, they burn very few greenhouse gases. So they have contributed the least to this problem. Regions in tropical Africa, Indonesia, South America, Central America, they have contributed very little to the problem. And so in that sense, they're virtuous. They have not really contributed to this global problem. And here's the irony. They are seeing the worst impacts of climate change. So those who had the least to do with creating the problem in the tropical regions, in the developing world, are seeing the worst impacts of climate change. And they're the most vulnerable because they have the least wealth and the least adaptive capacity to deal with these problems. In the industrial world, meanwhile, countries like my country, the United States, have been burning fossil fuels for 200 years. And so we have this legacy. We have contributed the most to this problem. Arguably, it means that we have the greatest responsibility to help solve this problem. The other very large emitter of carbon right now on the planet is China. And China, in fact, is doing quite a bit now to try to solve this problem. They are investing a lot of money in renewable energy. They are decommissioning their coal-fired power plants. So they're working hard to do their part to rise to the challenge. And we in the United States have to do more.
Talking about your last book, why did you decide to work with a cartoonist?
Well, I'm always looking for novel ways to communicate the reality and threat of climate change. Here in this museum, you all spend your time finding creative ways to communicate science to the public, to get them engaged. You can't just present them with equations and formulas. People often don't want to look at that. They aren't excited about that. So you have to make it interesting. That's what you do here in this Science Museum. You take science and you bring it alive and you make it fascinating to people and you engage them. Well, I try to do the same thing in my efforts to communicate the science of climate change. And one of the ways to do that is to use humor, is to use satire. And so when the opportunity came to me to team up with one of the great satirists in the United States, the cartoonist for the Washington Post, I jumped at the opportunity because it's a unique way to talk about the problem, and hopefully some people who so far have not become engaged in the problem of climate change, maybe we'll be able to get them engaged by presenting it in a different way, presenting it in a humorous way.
In your opinion, are science and politics two faces of the same coin?
Yeah, you know, science, in a sense, they are, because the implications of science often are political in nature. The science of climate change, for example, tells us that there is a problem with our ongoing burning of fossil fuels, which is contributing to the rise in greenhouse gases that are warming the planet. And that poses a threat for certain industries. The fossil fuel industry, of course, to some extent finds that science inconvenient because it challenges the notion that we can continue to extract and burn fossil fuels. It's having this negative impact on the planet. And because the findings of science have come into conflict with the interests of a very powerful industry, the fossil fuel industry, that has made the issue of climate change political. And the fossil fuel industry has at times funded organizations whose role is to try to discredit the science of climate change and to confuse the public and confuse the policymakers. It's somewhat like what happened with tobacco. We now understand that the smoking of cigarettes causes lung cancer and other human health problems. But for decades, the tobacco industry fought tooth and nail trying to discredit the science linking their product to these human health problems. Well, today, some in the fossil fuel industry are doing the same thing. They're trying to discredit the science. And so what that means is that if you're a scientist like myself, you find yourself at the receiving end of attacks that are intended to discredit you. And you need to fight back against those attacks, not just to defend your own work, but because the stakes are so great. This really is about what sort of planet we are going to leave behind for our children and grandchildren.
Did the Trump era truly mark an highlight in managing these topics?
Yeah, so Donald Trump, now the President of the United States, is the first president we've ever had who actually denies the science of climate change. He has dismissed climate change as a hoax created by the Chinese. And that's problematic for those of us who recognize that there's a worthy political debate that we can have about how we solve this problem. That's a worthy debate to have in our politics. But there isn't a worthy debate to have about whether the problem exists. And so we need to get past this denialism. We need to get past the sort of denial of the reality of the problem that we have right now in the US President Donald Trump, who not only denies the science of climate change, but has used his presidency to try to dismantle environmental protections that were put in place by previous administrations to protect our air, to protect our water, and to act on the climate change problem. Now in November, just months away now in the United States, we are going to have what are known as the midterm elections, where many of our Congress members are up for election. And some think it will be a referendum on Donald Trump, that this election will be about whether we're happy with the direction Trump is taking us or whether we want to go in a different direction. And many of us are hopeful that the American people will come out in that election and say, we want to go in a different direction. We recognize that climate change is a great threat to the entire planet. We recognize that the rest of the world is on board with solving this problem. The United States needs to be on board as well.
Do we still have time to change for the better?
We do still have time to solve this problem, to avert catastrophic climate change. We have gone too far down the road already. If we had acted on this problem when we first knew the problem existed several decades ago, it would have been fairly easy to make that transition away from fossil fuels to renewable energy, to hold the warming of the planet below catastrophic levels, where we commit to massive sea level rise, massive displacement of people around the world, tremendous increases in the severity of damaging extreme weather events. The worst impacts of climate change can be averted. We're already seeing damaging impacts of climate change now on a daily basis, but the worst impacts can be averted, most scientists think, if we hold the warming of the planet below about 2 degrees Celsius. Well, we've already warmed a little more than 1 degree Celsius, and there's probably another 0.5 degree Celsius in the pipeline from the greenhouse gases we've already put into the atmosphere as Earth continues to warm up in response. So that means we have a pretty small amount of wiggle room if we're going to avoid 2 degrees warming, catastrophic climate change. And that requires us to reduce our emissions dramatically in the years ahead. Now, the Paris Agreement was a monumental international agreement to act on the climate problem several years ago. The Paris Agreement gets us about halfway to where we need to be. Without the Paris Agreement, temperatures would be heading up like that. With the agreement, they'll head up like that. We need to bring them below that. So Paris gets us about halfway to stabilizing warming below 2 degrees Celsius. That means it's not just enough for the countries of the world, the United States, Italy, and everyone else, to meet their commitments under the Paris Agreement. We have to ratchet up those commitments in the next conference, the next international climate conference that'll be held within the next couple of years. So we're starting to turn that curve downward, our emissions curve downward. That's good, but we need to bring it down dramatically.
This is about education again. So how to attract the interest of young students in the topics of climate change and environment?
Yeah, thanks. We need to attract the best young minds to work on this problem because it's a truly interdisciplinary problem. The problem of climate change involves physics, it involves chemistry, it involves biology, it involves economics, it involves sociology, it involves everything. So there's a role for everyone, and we need people, we need young folks with interests in a variety of areas to become interested in this problem and to work on this problem. One problem in particular in the United States is that we don't do a good enough job in providing opportunities for young girls to get them interested in science. I have a 12-year-old daughter who loves math and science, and that's great. And you know, she has 2 parents who are scientists, and that might have something to do with it. But there are a lot of extremely intelligent young women in the United States, and I think this is true in other countries as well, who are turned away from science and mathematics, who are told that that is an appropriate field for women. And nothing could be further from the truth. Science benefits the most when we have a diversity of individuals contributing to the advancement of science. A diversity with regard to gender, a diversity with regard to ethnicity. We need to create as wide a tent as possible and bring as many sharp young people into the field of science in general, and hopefully into the area of science where I work, the science of climate.
Why a scientist with data, facts and information have still less power than politicians?
Well, it's absolutely true. If we lived in a world where all the decisions were made by scientists, then maybe we wouldn't have some of these problems. Scientists have their strengths and scientists have their weaknesses. Politicians are very skilled at explaining things to people, and they're supposed to be very good at understanding the issues. So my view is that as a scientist, my role isn't necessarily to prescribe what the policies should be. My role is to inform that discussion, is to make sure that our politicians are making decisions based on an objective assessment of what the science has to say about what the risks are. And too often, our politicians are listening instead to lobbyists, powerful interests who fund their campaigns, fossil fuel industry, other polluting industries. And in so doing, they're not doing what they were put there to do, which is to represent the people. So we scientists have an important role in trying to make sure that the policy debate takes place in an environment that is informed by what objective science has to say. There is a worthy debate, once again, to be had about how we solve the climate change problem. And there's room for people with widely differing ideologies and political philosophies in that discussion. But there is no room anymore for a debate about whether the problem exists and whether the risks are there.
So this is my last question, which is the evil question. Why should I change my habits while the big players around the world don't care about it?
Well, that question is in fact one of the most significant questions we struggle with today. People increasingly accept the science. We used to have a real problem in the United States, and I think here in Italy as well, with people rejecting the science, rejecting the notion that climate change even exists. Today, I think we face a different problem, which is this problem that people think climate change is so overwhelming, that it's so big that there's no way we can tackle that problem. And that sort of thinking, the despair, the disillusionment, pessimism, can lead us down the very same path of inaction as outright denial of the science. So it's potentially as dangerous. And that's why when we do communicate the risk of climate change and the urgency of acting, we also have to do a good job communicating the very real solutions that exist. We don't have to invent new technology to solve this problem. It already exists. On the drive up here to Trent, I went past massive wind farms, wind turbines. They're generating electricity from wind. There's a huge amount of sunlight here, and in this complex we have solar panels on the buildings. So here you see in Trent, or on your way to Trent, you see the solution. It's wind, it's solar, it's geothermal. Those solutions exist. It's simply a matter of us scaling them up. It's simply a matter of putting in place economic incentives that tell people to move away from fossil fuels towards renewable energy. We can solve this problem. We have the technology. All we need is the willpower.